Welcome back to Connect and Transform. We're continuing creating a text comparison tool for the web. I looked over this code and I found a couple things that need improvement. One thing is that here in while loop number 2, I think it would be most appropriate for these pointers to be incremented as the very last thing. So I basically just took this block of code and I moved it to the other side of this if statement. I'm not sure if that will actually change behavior, but it's not going to hurt anything. The other thing I noticed that will definitely hurt things is I have unbounded incrementers for these pointers here, and I believe the intention is this. So I'm going to copy this line of code from while loop number 1 and paste it here in while loop number 2. And so now we're only incrementing the processing pointer up to a point, up to the length of its corresponding file. Okay, so on to the next thing. I discovered the cause of a certain off by 1 error, specifically related to rules 5 and 6. So the issue is, after we create the group that only exists on either the right or the left, the intention is that we're going to break out of while loop number 2, loop back around, and that we're going to match on rule 1, rule 2. Okay, so to be specific, it's going to match whatever rule corresponds to this in while loop number 1. So that would be rule 2 here. So we're expecting it to loop back around and match on rule 2 to produce the match that's based on the processing pointers on both sides, whereas this loop is based on the range that the discovery pointer found. So the issue is that we're setting the processing pointer, and then we're breaking out of while loop number 2, and then we're immediately incrementing the processing pointer. So we're immediately losing our place. And that happens for rule 5, it happens for rule 6, and it also happens for rule 7, I believe, yes, because rule 7 is also updating the processing pointer, because rule 7 is a special case. That's basically the breakout case for the loop. So in other words, if rules 5, 6, or 7 run, then we don't want to execute this code. Otherwise, we do. So I think the easiest way, rather than putting in arbitrary, -1 offsets, I'm just going to keep track of the most recently applied rule. I guess we'll just initialize it as 0. And basically, anytime we increment the line iterator, we've applied a rule. So in this case, we're in the block corresponding to rule 1, so we'll set it to 1, 2, and so on. And then this would be the application of rule 5, 6, and then here we're creating not just 1, but 2 lines, so I'm just going to put it here. And there's a reason for that, because I'm probably going to be reading this value in rule 7 as well. So it's going to serve multiple purposes, and I'm not going to want to be updating this value in between creating these elements. And the reason that it might be important, specifically in rule 7, is recall that rule 7 is where you're creating 2 lines, right? So you're creating like a red and a gray. So the red's on the left, the gray's on the right, and then the very next line down, we're creating a gray on the left and a green on the right. In other words, we have 2 pieces of data, one on the left, one on the right, neither of which could be matched to anything and which don't match to each other. And so why might we need to know that we just ran rule 7 when we're running rule 7 again? Well, imagine the scenario where you keep hitting rule 7. Let's say we hit it 3 times in a row. Currently, where we're just appending these elements to the end of their corresponding containers, we would be thrashing back and forth, red and green, left and right, and grays mixed in everywhere. So I'm thinking that probably in a future video, we'll check and see if 7 was the most recently applied rule when executing rule 7, and we'll use that in some kind of if-else condition to determine where to append these new elements. The goal being that we can basically group the strong reds on the left and the strong rights on the green and not be thrashing back and forth. So let's continue. So most recently applied rule 7, and then most recently applied rule 8, most recently applied rule 9. Now finally, this is the very end of while loop number 1, and we do not want it to run when rules 5, 6, or 7 were just executed. So we're going to say if most recently applied rule does not equal 5 and most recently applied rule does not equal 6 and does not equal 7. So I'll save that. Let's go back to our browser, refresh, and select our left file and our right file. We don't have any errors. That's a good sign. Okay, I see this closing style tag, which we were missing previously. Let me scroll. I think it's line 1177 is one that was previously missing. Okay, and that's here now. That's a good sign. So we no longer have a missing line related to rule 7, and the closing, oops, sorry, it went back down to the bottom. Scroll up to the top. The closing style tag, which was previously missing, I think that was a result of rule 6. Let me search for rule 5. Okay, so I see, I know you can't read this probably, but this says L-122, 1, 2, 3, 4, 5, 6. So there's nothing missing there. 11, 12, 13, 14, nothing missing there. That's a good sign. Okay, so if I right-click and inspect this, we see that this goes all the way to 1216, which is actually higher than I was expecting, but I think that's right. Because it is 0 indexed, so what that really means is that there's 1217 total elements here. And I think part of that is probably an artifact of imperfect matching. So I think there's some cases where it's creating like a red line and a gray line and then a gray line and a green line, when it could really be matching the red and the green and produce a yellow and a yellow. So I think we still need to fine tune some of the rules, and but I do think that it is at least processing every line, although I know we're not seeing rule 9, rule 8, and I don't think we've seen rule 3. Let's see if we can get rule 3 to trigger. Let's remind ourselves of what rule 3 actually is. Okay, so this is the one where there's white space in the middle of the line. Let's see, I think I've got the files open here. So let me just go here. I'm going to scroll to the top of the file so we can see it right away. And maybe I'll just add, oh, but I have to remember, no, I think rule 3 would match. Anyway, let me just add some white space here, and then I'm going to add some white space here, specifically giving me at least 6 non-white space characters. So I'm going to save that real quick. And then we'll go back here, refresh, choose our files, left, which we just edited, and right. Okay, yes, so we do see rule 3 right here in blue, which has a slightly but very similar appearance to rule 2. Okay, so that rule is working. It just didn't happen to trigger based on the content and the order that things were executing. Okay, so at least we know rule 3 is working, so I'm going to go back here and undo those changes. So I think at this point, we might do some fine tuning of the precedence of the rules and other conditions around when the rules do or do not apply. And then that might open up the scenario where rules 8 or 9 happen towards the very end of the file. But I think that'll do it for this video. We're in a better place now than when we started. Thanks for watching.